Good morning, my dear students of first secondary. Today we are going to start our first lesson in trigonometry. This lesson is called directed angle. Let's go. First secondary trigonometry, unit 1, lesson 1, part 1, directed angle, prepared by Mr. George Milad. Measures of angles. The angle is a union of two rays with a common starting point, which is called the vertex of the angle, and the two rays are called the two sides of the angle. Okay? We all know that the angle is a union of two rays with a common starting point. The common starting point, which is O, is called the vertex of the angle. So if we have AOB, this angle is called angle AOB, or you can say angle BOA, or you can name the angle by its vertex. So you can say this is an angle O. But in this year, and because our lesson today is called directed angle, so the direction is very important. So here if we start with the ray OA, so OA is called the initial side and OB is called the terminal side, and the angle in this case will be called angle AOB, okay? Because here in this lesson we need to take care of the order of the two rays. Here we need to take care of the order of the two rays, okay? So, of which the angle consists. Then we write down the angle as form of an ordered pair. Here we write the angle in the form of ordered pair. The first component or the first projection is the initial side, and the second projection is the terminal side. So because the direction here is very important, so here OA is called the initial side, OA is called the initial side, okay? And OB is called the terminal side. OB is called the terminal side. Then the order pair OA and OB represent the directed angle AOB as shown in the opposite figure, while the order pair OB and OA represent the directed angle BOA as shown in the figure 2, and you will see figure 1 and figure 2. Okay? Here you can see that in figure 1, OA is the initial side, OB is the terminal side, and you should take care of the direction of the arrow. Here the direction of the arrow from the initial side to the terminal side. So the direction of the arrow is very important in this lesson. Here the initial side, this is the starting of the angle, and OB is the terminal side. So we can write this angle is angle AOB, and we can write it as an ordered pair of the two rays OA and OB. Okay? Tamam. In the second figure, here you have to concentrate. Here OB is the initial side and OA is the terminal side, because the direction of the arrow from the initial side to the terminal side. So AB is the initial side, OB is the initial side, and OA is the terminal side. So this angle is written as BOA angle, or we can write it as an order pair. Its initial side is OB and its terminal side is OA as an order pair. Example, check your understanding complete. Here is given to you that ED is the initial side and EF is the terminal side. Represent the directed angle. So here EF is the initial side. You will write initial side. And ED is the terminal side. Okay? ED is the terminal side. So ED and EF represent the angle. Okay? ED is the initial side, EF is the terminal side. So we will write the angle as angle write the angle DEF. Okay, this is angle DEF. Okay, in figure 2 here the angle is called angle XOY. Angle XOY. Look to the direction of the arrow. Here, this is the starting point, and this is the ending point. So, OX here is the initial side, OX ray is the initial side, and OY is the terminal side. Okay? OX is the initial side, and OY is the terminal side. So, you can write OX initial, and OY is the terminal side. Okay, let's go to another slide. Positive and the negative measure of the directed angle. The measure of the directed angle is positive if the direction of the arrow from the initial side to the terminal side, anti-clockwise rotation. So if the rotation is anti-clockwise, then the measure of this angle is positive. And if the rotation is clockwise, as in figure 2, from the initial side to the terminal side clockwise, so the measure of this angle will be negative. So the measure of the directed angle is negative if the direction of the arrow from the initial side to the terminal side is clockwise rotation. So here in figure 1, here in this figure, you can see that here the direction of the rotation from the initial side to the terminal side is anti-clockwise. This is anti-clockwise, okay, from the initial side to the terminal side. So the measure of this angle will be positive. So we can write 30, 40, 50, or 60, or any measure. But in the second figure here, the initial side is OA and the terminal side is OB, and the direction of rotation is clockwise, so the measure of this angle will be negative. Okay? So any directed angle has two measures. One of them is positive and the other one is negative. Okay? As you can see in the opposite figure, here if you are going to start from the initial side to the terminal side, you have two ways. Okay? If you start from OA to OB in the positive direction as this, so the measure will be positive. And if you start from the initial side to the terminal side in this direction, this is the negative direction, so the measure will be negative. So any directed angle has two measures. One of them is positive and the other one is negative. And the numerical sum of the two positive angles and the negative angle equals 360. Okay? I will give you an example. if the measure of this angle is 60 degree, and the measure here is positive because the direction of the rotation is anti-clockwise. So here the reflex angle AOB will be equals to 360 minus 60, and this is equals to 300 degree. So the measure of this angle is 300, but the direction of rotation is negative. So we will write this angle is negative 300. So the negative here doesn't mean that we have an angle of negative measure. No, the measure of this angle is 300, but the direction of the rotation is negative. Okay? Example. Complete the positive measure of the directed angle whose measure is negative 170. Here we have the negative measure of the angle, and we want to find the positive measure. To find the positive measure, we add 360. So negative 170 plus 360, it will be equals to 190 degree. Okay? The negative measure of the directed angle whose measure is 320. Here we have the positive measure and we want to find the negative measure. The negative measure of the directed angle, this is a positive measure. To find the negative measure, we will write 320 minus 360. So the result will be negative 40 degree. So the positive measure is 320 and the negative measure is negative 40. Okay, let's go to another example. Find the measure of the directed angle theta in each of the following figures. Here, the measure of the angle 42 is given to you, and he wants to find the measure of the angle theta. First, the direction of the arrow is clockwise. The direction of the arrow is clockwise. Okay, so the measure of this angle is negative. So we will write negative. And to find this measure, we will subtract 360 minus 42. 10 minus 2, this equals to 8. 35 minus 4 equals 31. So the measure of this angle is 318, but because the rotation is clockwise, so the measure of this angle will be negative 318 degree. Okay? Okay, let's go to another slide. Definition. Angle in the standard position. The directed angle AOB is in the standard position if the following two conditions are satisfied. So, the definition of the angle in a standard position, we have two conditions must be satisfied. The first one, its vertex is the origin point of the coordinate system. And the second condition, its initial side is positive direction of x-axis, which means OX ray. So, the angle in the standard position must satisfy two conditions. The first one, its vertex is the origin. The second one, its initial side is the positive direction of x-axis. Examples. All the following angles are in the standard position because they verify the two conditions. Okay, let's verify the two conditions together. In figure 1, you can see that here the vertex is the origin point. Its initial side is OX ray. The initial side is OX ray. Okay, so the two conditions are satisfied. The origin, the vertex is the origin point, and OX is the initial side. So this angle AOB is an angle in the standard position. Okay, in figure 2, you can see that Here the angle, its vertex is the origin point, and the initial side here, this is the initial side, is the positive direction of x-axis, and this angle is called angle AOB. This angle is a directed angle in the standard position. And you can see here in figure 3, angle AOB, its vertex is the origin point, okay, and its initial side is OX, which is the positive direction of x-axis. So we can say that angle AOB is a directed angle in the standard position. Okay, let's go to another slide. Another example. All the following directed angles are not in the standard position. Okay, all the angles are not in the standard position. Why? Okay, let's explain it together. Here in figure 1, in this figure, this angle is called AOB. Okay, here OA, this side OA is the initial side. OA here is the initial side, and OB here is the terminal side, because of the direction of the ray. Here the direction of the ray tell you that the initial side is OA and the terminal side is OB. So this angle is not in the standard position, because here it's the initial side, not the x-axis. Okay, here also in figure 2, this angle is angle AOB. Its vertex is the origin point, but here the initial side, this is the initial side. Okay, here the initial side is the negative direction of x-axis, not the positive direction of x-axis. So this angle is not in the standard position. The last one here, look to the direction of the arrow. Here OY is the initial side. OY is the initial side. OB is the terminal side. Okay, but here the initial side is not the positive direction of x-axis. Here the initial side is the positive direction of y-axis. So this angle is not in the standard position. Okay, let's go to another idea. Definition: the coterminal angle. What is the coterminal angles? Definition: the directed angle in the standard position. So when we are talking about a coterminal angles, we have two conditions. It must be a directed angle and in the standard position. Are said to be coterminal. These angles are said to be coterminal if they have the same terminal side. So the coterminal angles are directed angles in the standard position and they have the same terminal side. So if you have two angles having the same initial side and the same terminal side, you will say that the two angles are coterminal. Okay? So I will give you first an example. Okay? Here, this is x-axis and y-axis. Okay? Let's draw an angle of measure 30 in standard position. OXB. Okay? This is an angle of standard. This is an angle in the standard position. Its measure is 30 degrees. Okay? Here the initial side is OX and the terminal side is OB. If I write another angle, this is x-axis and this is y-axis. Okay? And here is the terminal side. Here O is the vertex, is the origin point, and here X, and this will be B. Okay? This angle will start from the initial side here and make one terminal, makes one rotation, its measure equals 360. Okay, so this angle is 30 and plus 360, which will be equals to 30 plus 360. And this is equals to 390 degree. So we can say that the angle of measure 30 is equivalent to the angle of measure 390, or the two angles 30 and 390 are coterminal angles. Why they are two coterminal angles? Because they have the same initial side, which is OX. Here it has the same initial side, it has the same initial side OX, and it has the same terminal side OB. But the difference between the two angles, that the first one is 30 and the second angle is 30 plus one turn, which is equals to 360. So it will be 390. Another example, here this is the origin point, the vertex OA, and the initial side is OX. Here the angle will start from the initial side and make one turn, which is equals to 360, and another turn, which is equal to 360, and go back to the same terminal side, which is OB. Okay, so this angle, its measure is 30 and it has two turns plus two turns, so its measure will be equals 30 plus two turns, 360 plus 360. So this is equals to 750. Okay, so you can say that the measure of angle 30 is coterminal to the angle of measure 390, and it's also coterminal to angles of measure 750. Or you can say it by another way, the angle of measure 30 is equivalent to the angle of measure 390 and equivalent to the measure of 750, because all these angles having the same initial side and the same terminal side. Okay, let's go to another slide. Examples. Find two angles where one of them is positive measure and the other is negative measure, such that each of them is coterminal to each other, to each of the following angles whose measure as follows. Here we have an angle, its measure is 85, and we need two coterminal angles. One of them is positive and the other is negative. Okay, to find a positive coterminal angle, we add 360, and to find a negative coterminal angle, we subtract 360 from the given angle. Okay, so for example, here we have 85. If we want to find another coterminal angle to it, and it will be a positive measure, so we will add 360. So the result will be 85 plus 360, which is equals to 445. Okay, here we want to find a negative measure, so we will subtract 360 from 85. So here it will be 85 minus 360. 85 minus 360, it will be equals to negative 275. Example 2. Here we have an angle, a negative angle. Its measure is negative 200 degree and 23 minutes. Okay, to find another positive angle to this angle, another coterminal angle, we add 360. So negative 200 degree, 23 minutes, plus 360, it will be 159 degree and 37 minutes. And to find a negative measure to it, okay, negative 200 degree and 23 minutes, we will subtract negative 360, so it will be negative 223 Here, I will explain it to you. It will be right down now. Here it will be the first one, negative 200 degree and 23 minutes plus 360. So the result will be 159 degree and 37 minutes. But to find another coterminal angle, we subtract 360. So it will be negative 200 degree, 23 minutes minus, just a moment please, minus 360. So it will be negative here, negative 200 degree. I will write on my calculator, negative 200 degree and 23 minutes minus 360. This is equals to negative 560, negative 560 degree. It will be equals to negative 560 degree and 23 minutes. Okay? If you try to add another 360, okay, it will be again negative 200 degree and 23 minutes. Another example, here 555. Okay? Here you have an angle bigger than 360. So if you have an angle, its measure is bigger than 360, you have to put it in the form of an angle from 0 to 360 first. So to put it between 0 and 360, you will subtract from 360. So first, you will take the angle 555, okay, subtract negative 360. So this is equals to 195. So now 555, this angle is bigger than 360. And we need to put it in the form of an angle bigger than 0 and smaller than 360. So we will subtract 360 from it. So the angle will be 195. We want to find a negative measure to it, so we will subtract 360 from it. So 195 minus 360, this result will be equals to negative 165. Okay? So the two measures will be 195 and negative 165. Okay? Here, example for negative 11 over 8 pi, we will talk about pi in the next lesson, in lesson 2. Okay? Okay, let's go to another idea. If we draw the directed angle AOB in the standard position, whose positive measure is theta, then its terminal side OB lies in one of the four quadrants that the Cartesian coordinate plane is divided into by two coordinate axes as shown in each of the following figure. Okay? Here we are going to focus on the terminal side. Okay? So in the first figure, in figure 1, here the vertex is the origin point. The initial side is OX, the positive direction of x-axis, and the terminal side here, OB, lies in the first quadrant. So if the terminal side lies on the first quadrant, this means that theta bigger than 0 and smaller than 90. Okay? In the second figure, you can see the angle AOB is an angle in the standard position. Its vertex is the origin point and its initial side is OX. The terminal side OB lies in the second quadrant. So the angle AOB is an obtuse angle. So its measure theta is bigger than 90 and smaller than 180. Okay? So if you have an angle, its measure bigger than 90 and smaller than 180, you have to know that its terminal side must lie in the second quadrant. Okay? In the third figure, here the angle, its vertex is O, is the origin point, its initial side is the positive direction of x-axis, and the terminal side OB lies in the third quadrant. Okay? Here also you have to know if the angle lies on x-axis, so its measure is 0 degree, and here the angle is 90 degree, and here the angle is 120, and here the angle is 270 degree. And if the angle makes one turn, so it will be 0 degree or 360 degree. Okay? Again, in the third figure, this angle will be 0 and 90, here 180, 270, and one turn equal 360 degree. So if the terminal side lies in the third quadrant, this means that theta bigger than 180 and smaller than 270. Okay? The last one. Here also angle AOB lies in the terminal side lies in the fourth quadrant. So angle AOB lies in the fourth quadrant. That is to say that theta bigger than 270 and smaller than 360. Very important remark. If the terminal side lies on one of the two axes, then the angle is called quadrantal angle. Okay? You have to memorize this expression, quadrantal angle. So the angle whose measure 0 is called the quadrantal angle. The angle whose measure 90 is called the quadrantal angle. And 120 or 270 or 360 are, all of them are called quadrantal angles. Okay? Let's go to another slide. Exercises. Complete each of the following. Complete each of the following. The negative measure of 75. Here you can see that 75 is a positive angle, and here we need to find the negative measure. Okay? Here we want to find the negative measure. So to find the negative measure, you have to subtract. Very good. So we have 75 degree. We want to find the negative measure, so we will subtract 360. So it will be 75 minus 360. This is equals to negative 285. Negative 285 degree. Example 2. The negative measure of 132 degree and 25 minutes. Here 132 degree and 25 minutes, this is a positive measure. We want to find the negative measure. So we will subtract 360. So it will be 130 degree, 25 minutes minus 360 degree. By using your calculator, 132 degree and 25 minutes, okay, minus 360. This is equals to negative 225, negative 227 degree and 35 minutes. Okay. Again, the negative measure of 0.375 pi. Pi again, we are going to talk about it in the next lesson. The positive measure of 175. Okay, here we want to find the positive measure. Okay, the positive measure of 175. Here 175 is the negative measure, and we want to find the positive measure, so we will add 360. So it will be negative 175 plus 360 degree. Okay, by using your calculator, negative 175 plus 360 degree This is equals to 185 degree. Okay. The positive measure of 280 degree, 36 minutes and 25 seconds. Again, by using your calculator here, we want to find the positive measure. So this is negative 280 and 36 minutes and 25 degree. So to find the positive measure, we will add 360. We will write negative 280 degree and 36 minutes 25 seconds minus 360 degree. Okay, plus 300. This is a negative measure and we want to find a positive measure, so we will add 360 degree and the result will be 79 degree and 23 minutes and 35 seconds. Okay, let's go to another example. The positive measure of 3/4 pi. Okay, example 7, the angle whose measure is 179 degree and 59 minutes lies in space quadrant. Okay, here this angle 179 degree and 59 minutes is bigger than 90 and smaller than 180. It's bigger than 90 and smaller than 180. So it lies in the second quadrant. Okay, the angle whose measure is 1351. Again, we don't have an angle of measure 1351. So we have to put it in the form of an angle from 0 degree to 360 degree. So here you have to subtract 360. Okay, so we will write 1351 minus 360. This is equals to 991. 991. Okay, this is also is bigger than 0, bigger than 360. So we will subtract again, minus 360 is equals to 631. It's also bigger than 360. So we will subtract again negative 360. It will be 270. So we can say that the angle 1351 is equivalent to an angle of measure 271 degree. 271 degree, this angle is bigger than 180 and smaller than 270? No. This angle is greater than 270 and smaller than 360. Okay, 271 bigger than 270 and smaller than 360. So this angle lies in the fourth quadrant. Very good. This angle lies in the fourth quadrant. Here, example 9, the angle whose measure is negative 299 and 30 degree. Here, this is a negative angle. It's better to transfer this angle to a positive one. Okay, to know its quadrant, you have to change it from the negative measure to the positive measure. So we will write negative 299 degree and 30 minutes, okay, plus 360. This is equals to, this angle is equivalent to 60 degree and 30 minutes, okay. This angle is equivalent to 60 degree and 30 minutes. So the angle whose measure is negative 299 degree and 30 minutes lies in the first quadrant. Okay, lies in the first quadrant. Okay, thank you so much. Until we meet again next time, goodbye and good luck. Okay, this is the solution of the last example. Okay, I write it again for you. This is all the answer of the previous example. Okay, thank you, my dear student. Until we meet again next time, goodbye and good luck.